So is it easier now to solve joint B? Remember when we first evaluated it, it had three unknowns. Now it has just two unknowns because this force is now known. So let's study joint B. So I'm going to go ahead and just do a little separation here. This is joint B. So what is the free body diagram of joint B? Well, I like to do the imaginary scissors. I will start here. Include the external load. So I'm going to put joint B. I'm going to put the external load, and it's 6 kilonewton going downward. I will continue the dotted line. I will intersect member BA. So I will replace this with a force in the same direction as member BA. So what do you want to assume the direction of this force? Do we know it? Did we calculate it from another joint? The answer is no. So it's a new force. If this is a new force, we have to assume it as tension in order for this rule to work. For tension positive, compression negative, I have to assume new forces as tension. So I will put a tension force like this, and we'll call this force AB or BA. Both are the same. All right. So is this the free body diagram? Am I done? No, I need to finish the dotted line until I stop where I started. So I'm going to continue. I'm going to come across another member, a BD. So BD is vertical. I will put a force. Do we know this force? We know that this will be BD. Is this force that we calculated before, or that's the first time we consider it? The answer is it's the first time we consider it, and that's why I will assume it as tension in order for this rule to work. All right. I'm going to continue with the dotted line. I'm going to hit another member. So this member will go this way. And the question now is, do we know this force? And yes, we do. We know the magnitude and direction. Force BE happened to be 5 kilonewtons, and it's tension. So what's the direction of tension? It's actually going this way. What's the magnitude of this force? It's 5 kilonewtons. That's excellent. All right. So am I done with the free body diagram? Well, if I can reach where I started, then everything inside the dotted line is in equilibrium, meaning these forces are in equilibrium, and therefore the summation of forces in x equals 0 and summation of forces in y equals 0 applies. So I'm going to apply these two equations. Which equation do you want to consider first? The summation of forces in x or the summation of forces in y? Sometimes it's better to consider one direction first, because you can get an unknown quicker. But in this case, it doesn't make a lot of difference, because the 5 kilonewton, we will get it in the x component and the y component. So what is the angle theta? The angle theta is between this line and the horizontal. So if you put a horizontal line here, then it's the same angle. This is angle theta. There is, like, we always look for this Z kind of shape. This is theta and this is theta. You can think of it this way. Theta is between this line and the horizontal. So if there is a horizontal line here, then this is the angle theta. All right, so if this is theta, that means 5 cosine theta. We know that cosine theta is 0.8. So 5 multiplied by 0.8. This will leave us with the 4 kilonewton. So the x component is 4 kilonewton, and the y component is the force sine theta. So the force is 5, sine theta is 0.6. So this happens to be 3 kilonewton. So are we going to consider the 4 and 3, or are we going to consider the 5? The answer is you replace this force with the 2 components. All right. So if you want to look at the summation of forces in the x direction, let's consider this equation 1. Summation of forces in the x direction has to equal 0. So force BA is unknown and it's going in negative x, so I will consider negative BA going in negative x. Is there any other forces in x? Yes, there is 4. So it's going positive x, so plus 4 has to equal 0. This will result in BA is positive 4 kilonewton. What does the positive mean? It means that the assumption is correct. It means that positive is tension. So BA here is positive 4, and the answer is tension. This is great news. So in this joint, we have another equation, equation 2, which is the summation of forces in y has to equal 0. This is interesting because now we have 3 forces. They are all going in the same direction. Let's consider this as negative y. So I will start with the 6. It's going negative y, so negative 6. There's another force called BD. It's negative as well, so negative BD. And there is 3 going downward, negative 3. Is there any other forces in the y direction? The answer is no. So what happens when you kind of add all these numbers? They have to equal 0. All right. So if you move dB on one side and get everything else in the opposite side, so you will realize that dB is actually negative 9 kilonewton. So what does that mean? That the negative sign. So by now we know that this means compression. So BD is going to be 9, and it's kilonewtons in compression. All right, so we are getting very close to figuring out all the forces. You can see that we just have one force that is unknown, but I just want to quickly show you what is the correct direction on the truss. So AB or BA happen to be tension, and it's 4. So BA is tension. What is the correct direction of tension on this joint? It's going away from B. This is the correct direction of tension. So before you forget, Consider tension on A as well. So now consider yourself at A. Put your finger at A. What is the direction of tension in member AB? It's away from A. So therefore, the forces are equal and opposite on both ends of the truss. It's tension on B and it's also tension on A because there is tension everywhere in this truss. Let's consider BD. So BD is negative. So negative is compression. What is the direction of compression on joint B? Is it away from B or is it into B? Compression is into B. So I will just take a compression force into B and before I forget, equal and opposite on the other end of member BD. So that means there's compression on joint D as well. All right, so you can see here the only joint that, or the only member that we haven't got is AD. So we have two options. We can analyze joint D, or we can analyze joint A. So it's not going to matter much because we have 4 unknowns here and 4 unknowns there. So we might as well consider joint D.